All right, here we are with the second method of solving first order differential equations, and that is to recognize when they are a linear first order ODE. And then we've got this cookbook technique. All right, so we'll be doing that technique for this same problem here. dy dx is minus 3 times y minus 20. Okay, so the first thing to do is to put this ODE into standard form. So the right-hand side is minus 3i plus 60. Okay, so this is dy dx plus 3y is equal to 60. This is in standard form. Okay, here we've got this p of x is 3, and here we've got the q, try to call it g. G of x is 60. And you say, well, wait a minute, 3 isn't a function. 60 is not a function, but yeah, so we're allowing the possibility of something like 3 times e to the x here, any old function of x. But this is a fine function. It's the constant function. Okay? So we do that, and you might remember that if 60, if it's equal to 0 on the right-hand side, then that would be homogeneous linear ODE, but this is non-homogeneous. Okay? So what we do here is we compute the magic integrating factor, mu of x is x of integral of p of x dx. So we like, this is really the same as e to the, but when you have e to a big fat hairy mass, we like to write it as x of that. So this is, let's write down here. So this is x of 3 integral of 3 dx. Okay, go up here. So that means that mu of x is e to the 3x plus a constant, right? Okay, well, this is equal to e to the 3x times e to the c. All right, but in this case, I can choose c equals 0, so e to the c is 1, and I get mu of x is e to the 3x. So I say it's a magic factor because my claim is if I multiply the differential equation in its standard form by mu, then something great happens. I'll show you that in a minute, but I also mentioned this in the standard form because if this started out with like an x in front of dy dx and I divided through, like to put it in standard form, I'd have to multiply mu of x times this standard form, not the original one, okay? And by the way, in standard form, the thing about it is there's a 1 right here. There's no coefficient that I see in front of dy dx. That means it's a 1 there. So that means that I multiply through by e to the 3x. So I get e to the 3x times dy dx plus 3y is equal to e to the 3x times 60. Okay? Or, all right, or let's say, I don't know. Let's do it this way. dy dx times e to the 3x plus 3y e to the 3x is equal to 60 e to the 3x. Okay? Now, this is the magic thing. If I did it right, and it's always a good idea to check it, if I did it right, this left-hand side is the d dx of y times mu. In this case, y times e to the 3x. And that is 60 e to the 3x. Okay? Now I should probably check. I should check that indeed these are the same things, because I might have made a mistake. Okay? And also, I point out that what I'm about to do, okay, really requires that I've simplified mu. This mu of x is already pretty simple. But if the mu of x involves something that looks really complicated, like it's e to the 5 log of x squared plus 3 or something, you got to simplify it often. Okay, let's keep going. So what is the derivative of this from the product rule? The derivative of the first, dy dx, times the second, e to the 3x, plus the first, y, times the derivative of the second, e to the 3x times 3. So check that these are the same. You don't have to write it down, but you should check it in your head. Yeah, if I differentiate this using the product rule, I get that, right? So this sort of is the derivative of this kind of new unknown function. I was looking for the unknown function y, but now I have got the unknown function y, or y of x, times e to the 3x. That unknown function has its derivative to being that. But we know how to solve that from Calc 1. If the derivative of a function is that, then the function is the integral of that. We get that y, e to the 3x, is the integral of 60 e to the 3x dx. All right? Okay. And now I said earlier that the most important thing you need to know about differentiation is the chain rule. Good example here. Give me a function whose derivative is 60 times e to the 3x. Well, if I know the chain rule, that's 20 e to the 3x plus an arbitrary constant. The derivative of this is 20 times e to the 3x times 3. 20 times 3 is 60. All right? So that's y e to the 3x is that. Well, I want to solve this guy for y. So y is, maybe I'll do it in 2 steps, 20 e to the 3x plus c. That whole thing gets divided by e to the 3x, including the c. A lot of times people leave that out. So this is 20. I'll write it out. You may not have to. Well, these guys cancel. And in calc, so y is 20 because e to the 3x over 3x is 1. And then in calculus or algebra, we usually like to trade e to the 3x on the bottom from e to the minus 3x on the top. So that's plus c, e to the minus 3x. That's the same thing that I got kind of by inspection. I said, verify this is a solution. Of course, I forgot the minus sign, but then I fixed it later. And then we found the same solution by separation of variables, and I called it C-twiddle there. And now we found it by using the cookbook technique to solve any first-order linear ODE. All right, bye.